Okay, let's start section 3.4. We're talking about polynomial functions again. And the goal is to graph a polynomial function. Eventually we'll get to something complicated like x cubed minus 7x minus 6. First, let's just look at a function like negative 2x to the fifth. And before we even get to that, the first thing we need to say is that the basic shape for y equals x squared, x to the fourth, x to the sixth, or any even positive power of x looks the same. What does that graph look like? Well, we already know because we've studied the graph of x squared, and so that's a parabola with vertex at the 0, and it opens up. And if we have x to the fourth or x to the sixth, the graph is very similar. The only difference is that it'd be a little steeper on the sides and a little flatter across the bottom. But the basic shape is the same. So there's our graph. And then we can make a similar observation for the odd powers of x, like x cubed or x to the fifth or x to the seventh. We can say that all those graphs look just about the same. And we can sketch that graph because we know the graph of x cubed. Okay, so if we want to graph negative 2x to the fifth, then we could start with x to the fifth, and then we could look at the negative 2 as a couple of transformations of the graph. So that's what we're going to do here in this first example. We're going to use transformations to graph the following functions. So we did this in chapter 2. Do you remember the steps? First step was to say, what's the basic function? The next step was to describe the transformations in words. And the last step is to sketch the graph. Okay, so in this first example, the basic function is y equals x to the fifth, or we could say x cubed, since again that's the same basic shape. We're not trying to be too precise. We just want the basic shape of the graph. So then the transformations. We're multiplying the x to the fifth by negative 2. So remember, we need to think of the negative and the 2 separate from each other. If we multiply by 2, then that represents a vertical stretch. And if we multiply by the negative 1 in front, then that represents a vertical reflection. And so what we're going to do in this first example is we're going to go ahead and sketch the basic graph, x to the fifth. And then we're going to sketch the stretch. So vertical stretch is going to pull the graph away from the x-axis. Where we're below the x-axis, we get further below, we get steeper. And where we're above the x-axis, we get further away above, we're steeper. And so then there's our stretch, and then we can come back and we can do the second transformation. We can just reflect this thing over the x-axis, and we wind up with something like that. So let's go ahead and label the red graph, f of x equals negative 2x to the fifth. And let's go back for just a second and let's graph y equals, let's label the graph of x to the fifth, and then let's label the graph of 2x to the fifth. And we're done. Okay, so let's do it again. Basic function, transformations, and then the graph. What's the basic function this time? I bet you said y equals x to the fourth, and you said that looks like x squared. What are the transformations? We have a -2 inside the basic function, so that would be a shift to the right 2. And then we have a -3 outside the basic function. That's another shift. Can you read that, D? Maybe we better fix that. Okay, shift down 3. And all that's left is to make the sketch. So once again, we'll start with the basic function, x squared, or x to the fourth. We'll take it to the right 2 units. So we start from the vertex. We move the vertex over from 0, 0 to 2, 0. And then we sketch the parabola from there. And then we're going to shift the graph down 3 units. So where does the vertex wind up? If you said 2, -3, that's exactly right. And I guess the only thing left is to label the graphs. X -2 to the fourth -3. The intermediate graph was x -2 to the fourth. And the original was x to the fourth. Okay, that's it for transformations.